Hello, what is up? This is Postdoc Chronicles, week number 120. And today we're talking the most recent shmup release on the Nintendo Switch, which is Crimson Clover with a Z, Crimson World Explosion. So this one, I'm not sure if it's very clear with the lighting and all, but this one is like an extreme or like the ultimate version of a game previously released on the Steam called Crimson Clover World Exhibition or something like that. And it's very amazing, like because I believe one of like the developers who did this game is like I'm not sure if they're like former cave employees, and then there's also a guy involved who holds like a record for the Donpachi, high score, something like that. But anyway, so rest assured, the guys who made this are like very well versed with shmup. And then again, so the mechanics that you have here are really tailored to shmup fans and all those things. And in fact, how do you call this? This game reminds me a lot of another game on the Dreamcast, which I'm gonna show here. This game is called the Ketsui. And if you're hearing like some sort of vibration, that I apologize for that. That's the electric fan of my Pi Boy DMG, because I've been playing with it. The electric fan goes turbo mode when it gets hot inside, because it's a Raspberry Pi 4. It needs an active cooling. But anyway, it reminds me of the Ketsui game by Cave. This one is by an indie company. I forgot their name, but on the Dreamcast and then on the arcade, you have this game Ketsui that relies on a targeting system. You have like a mini weapon that auto targets enemies. When you hold it, your ship kind of slows down, and then it auto targets the enemies. And then I call this like some sort of in your face shmup, because what you do is, in order to have a huge high score, you have to like go towards the, because your enemy, they drop these some sort of cubes, and then you have to like go in their face and then collect the cubes. And then once you collect it, there's like a timer on like the upper left, and then you have to like wipe out as many enemies as you can before the timer runs out. And then if you can do that, then you'll have a more insane high score. And then the auto targeting here, so let me turn this off very quickly, my Pi Boy DMG. The auto targeting here of the Taketsui game, which we're emulating on the Pi Boy on the arcade, is used here. So in here, if you press a specific button, you have like a circle surrounding your ship, and then all the enemies are like that are auto targeted within that circle. And then when you release the button, there's like a bunch of missiles that basically wipe them all. And then on top of that, of course, you have your usual fire mode, and then you have like a gauge that charges, and then there's like a specific bar that when the gauge reaches that bar, you can use a screen clearing bomb, as usual with the bullet hells or with shmups. But the nice thing is you can't really spam it, because when you use it again, then the gauge where you have to charge your bomb will go higher and higher. So if you like spam it, then it will require more and more gauges. But the coolest thing, the unique thing here is, once the gauge becomes full, there's this thing called what's it called? Is it like a burst mode or something like that, where or beast mode or something, where your ship, your damage becomes huge, and then you have like some sort of shield. And then when you double that, when you fill the gauge again, you have like a double burst mode, where it really goes insane. And the trick is, you have to time it such that the moment you do the burst mode, while in the first burst mode, you connect enough bullets such that the second burst mode again gets activated. It's very amazing. I believe it was released like end of October or something like that. It's $20 though on the eShop, but there are like a lot of extra stuff that are in here, like a lot of variations of the Crimson Clover formula. So there's like a mode where I believe it's called arrange mode, where instead of the usual arcade mode, it looks like Gradius. Like you collect, once your gauge is filling up, you have these different level ups, like we've seen in Gradius. And then it's an entirely different mechanic, but the graphic is very good. It's insane. Of course, it can go tate mode, just as usual with our arcade shmups. But anyway, highly recommended new shmup right there. So the Switch is becoming a home for these amazing classic shmups on the old consoles, or even in Steam. But anyway, going to Postdoc. So this week I focused on writing the paper, because Jong and Roberto, we had to meet like last Wednesday to flesh out a draft, and then to see what we still need to do. And again, we've been working on this paper paper still from last year, and the delay, or the thing that really took us a long time is, we really want to include the matching when scanning the MUED parameter space, because again, when you just use Pythia, there are like old papers where they scanned some other stuff, not MUED. But when you just use shower, they showed that there are variations when you just use Pythia showers. And then in the older parameter scans of MUED, there are people who did the scan but then also only use the shower. And again, it's very important to instead of having a shower on top of a shower, you introduce some additional jets, up to 2 jets, and then you match them with a Parton shower. Because again, if you don't do that, when you change the evolution starting scale of your Parton shower, for example, I think the two extreme cases is when you set it to wimpy, between wimpy and power. When you set the two of them, the distributions that you get, for example, for the PT of a gluon, or the final states, are really, the uncertainty is really, really very large. It's unacceptable, especially the moment you go to very compressed spectra of the mass spectrum of the benchmark point that you're trying to look at. And so that was like the main goal of our paper, on top of just merely updating the exclusion limit of the different MUED variables, which of course there are only two: the lambda r, and the r is the compactification radius, and also 1/r. Lambda is of course your cut. So technically you only need r, the compactification radius, but then you get a non-renormalizable theory. So you have to introduce a cutoff such that and your energy scale of interest is just below that cutoff. So that's why you have a lambda as well. But anyway, yeah. So lambda r and then r minus 1, we have a limit plot around that. Of course, there's a paper from 2018, I think, or 2017, where they have the limit plot of lambda r. We showed that, again, with the new data from run 2, that limit, that exclusion limit, is even more stricter this time around when you include the most updated search. In fact, one of the recent searches that we have is that we're gonna add is this thing called the monojet search, which I mentioned a few postdoc chronicles ago. So it's like an updated monojet search from, I think the old one was 2017 or 2016. I'm not sure, but yeah, there's a new one in 2020. It's not yet published. I'm also doing that analysis and then validating that analysis for Checkmate. So that's why. And then once it's validated, we're also gonna include that. So the problem is, again, since it's not yet published, there are no event files. There are no cut flows on the hep data.net. So I can't do the usual validation where I generate my own events and do a cut flow by cut flow comparison between the Checkmate analysis and then the analysis used by that particular search, which is I believe Atlas. And so what we do is we rely on the exclusion plots that they have. We look at, we use like a web digitizer or something like that to pick out values of benchmark points that are on the boundary of the exclusion limits of the ones that they have. So in particular, I picked S bottom decaying to a bottom and a LSP light as a supersymmetric particle, the neutralino. And then so we look at that mass parameter space, and then I pick a benchmark points along the boundary, and then I run that particular generated events on Checkmate, using the analysis that I'm trying to validate. And then, of course, one thing that you should expect is, since it lies along the exclusion line, then it should be excluded, So that's what I have right now. I was able to show that indeed not all, of course, because there are infinite points in a line, but the specific benchmark points that I picked along the line are indeed excluded. And also now, but the thing is, it is excluded by, I think, currently the analysis that we have is for the monojet is very strong, because yes, it is excluded, but it's very high. The R value is very high. It's like 1.4, 1.5, when we should expect that it should be around 1. So in other words, the analysis that we have on Checkmate is, even if we want to look for the R equals 1 contour line, ours is even stricter. So now what I'm gonna do is I'm gonna pick points away from that line that shouldn't be excluded by Atlas, but for some reasons our Checkmate analysis is still excluding that R equals 1 contour line. And so what happens is, I want to see at least, or we want to show that that discrepancy is not that large, because if it's huge, then there's something wrong with the monojet analysis, and so it means that the validation failed, and then we have to, we have to look over the code again and then change some stuff, because for some reasons the analysis is way stricter than the one we have. And also, so now it's in Overleaf. The MUED paper, the temporary title is some MUED and where MUEDs and where to find them, of course, as a reference to Fantastic Beasts and where to find them, because what we're basically doing is which values of the parameters that dictates MUED should you look for, to make sure that the MUED model you're looking at is not yet eliminated by the run to searches. That's why it's called MUEDs and where to find them. So hopefully the collaborators will agree. So it's a temporary title, but if they agree, I'll really be happy. But yeah, that's why I believe, this particular postdoc chronicles will also be called MUEDs and where to find them, because that's really the title I want for this particular paper. But yeah, we're hoping to be able to submit it on arXiv, like I believe before the Christmas break. Jong said if we can't make it before Christmas break, then we have to submit it early 2021, because no one would be reading, arXiv like during the Christmas break. But yeah, I'll try my best to be able to submit it like before the holidays. But anyway, by the way, I think again this week I'm going to be focusing again on the R19, R21 update for the Atlas PMSSM general scan, because I think I'll be giving a talk again this Friday, so I'm gonna focus on that as well. And also, finally, I have like a call. I made like an advertisement for our subgroup, my upcoming subgroup in National Institute of Physics, because I talked to Sir Perry. We were chatting on Facebook. I told him, sir, can you like advertise my upcoming subgroup just via word of mouth? Just tell them that Dr. Flores is interested in beginning to assess some students. But then he asked me for a poster. Like, okay, where's your poster so that I can show them? So I had like to make a poster, and then I gave it to Dr. Sigera, I gave it to Sir Ian. So currently I already have like some inquiries from majority of them are like MS students, but yeah, I already have some inquiries from them, and then yeah, we'll see. But because I'll be returning at the latest June 2021. Okay, maybe I can return earlier, but again, my contract here is until May 2021. But anyway, this has been Postdoc Chronicles week number 120. Thanks for watching. See you next time, and bye bye.